Hello, hello, hello. My Cox. Hello, 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 hello. Is there sound coming for audio input? Audio input. अच्छा audio input. वीडियो कहाँ चला जाता है? Oh god. अच्छा अच्छा अच्छा. Hello. Okay. That's better, right? The Droid cam is not working, so let's go on. Come on, okay. So we have started till the multiplexer. We're going to the multiplexer. Just about to.
And it is very important to understand this one. So the first thing that comes in my mind is that using enable, we can implement this thing. Because in the last presentation, when we implemented 8 cross 1, by using 2 cross 1, we assume that the enable of all the 2 cross 1 multiplexer is high, which means that the circuit or the multiplexer is always in the working mode. But in this, the enable is varying. We will vary the enable to obtain 8 cross 1 mux. So let's see how we can do it. The most important thing and the most helpful thing in the mux tree is this table. This table gives you all the ideas to implement the higher order mux by using the lower order mux. So let's use this table. Before that, I will make two 4 cross 1 mux that we will use for the implementation, and let's give 4 input to each of these mux.
So that we need to make 4 cross 8 cross box using 4 cross box. Okay. How many do you think we need? 8 by 4, 2. 2 by 4, half.
This is going to use 2.5 mux. It means that all of the input of the third 4 cross 1 multiplexer is not used. So this is a problem. We cannot use that method to implement in this case. So what we can do, we are going to use a completely different approach in this implementation. That's why we call it as a special case. And it is very important to understand this one. So the first thing that comes in my mind is that using enable, we can implement this thing. Because in the last presentation, when we implemented 8 cross 1, by using 2 cross 1, we assume that the enable of all the 2 cross 1 multiplexer is high, which means that the circuit or the multiplexer is always in the working mode. But in this, the enable is varying. We will vary the enable to obtain 8 cross 1 mux. So let's see how we can do it. The most important thing and the most helpful thing in the mux tree is this table. This table gives you all the ideas to implement the higher order mux by using the lower order mux. So let's use this table. Before that, I will make two 4 cross 1 mux that we will use for the implementation, and let's give 4 input to each of these mux. This is I0, I1, I2, I3, similarly I4, I5, I6 and I7. This is 4 cross 1, 4 cross 1 and single output to each of these mux. Now what about the select line? In 4 cross 1 multiplexer, there are two select line. But in 8 cross 1 multiplexer, we are having 3 select lines. So how you are going to have the third select line, because you are having 2 select line? It is implemented by using the enable. Let's say this is enable of this marks E and this is enable of this marks E. Now I will give a signal or an input S2 and this will be complemented and given to E, the E of this, and it is given to the enable of this in uncomplemented form.
Mm, 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 mm. Ah, the enable.
Let's see what is the advantage of doing this. For the first four cases, S2 is 0. So let's consider the first four cases when S2 is equal to 0. By doing this, this multiplexer will not work. Why? Because enable is low, and when enable is low, the output is always equal to 0. But this multiplexer, here it is 0, so it will be 1. Enable is 1, so it is working. And now the output depends upon the select line. And I will say it is S0 and it is S1. So this will be S0 and this will be S1. So if it is 0, 1, then I1 here will be reflected. And now out of I1 and 0, what we want? We want I1. So I'm going to use
But there is.
a OR gate here, because using the AND gate will always result the output is 0. Because every time out of these two marks, this one or this one mark is not going to work. And output is 0. So if I use AND gate here, the output is always 0. So I'm using the OR gate.
Oh,
And
good.
now Y is I1 or 0, which is equal to I1. Let's check for the other case when S2 is not equal to 0, but it is equal to 1. So when it is equal to 1, this multiplexer is working, okay, but this multiplexer will be disabled. So the output is 0 in this case, and here the output depends upon the value of S1 and S0. Let's say it is 1, 1. When it is 1, 1, the output here of this multiplexer is I7. So Y is equal to 0 or I7, which is equal to I7. And
तो ठंडा इतना है जो गाड़ी बढ़ रहा है साला फिर रखियो बताओ Sorry for the interruption, but I need to do that. Oh God, it feels good, huh?
when we get I7, when S2 is equal to 0, S1 is equal to 1, and S2 is equal to 1, S1 is equal to 1, and S0 is equal to 1, which is the same case here. And when we get when S2 is equal to 0, S1 is equal to 0, and S0 is equal to 1, which is the same case here. So in this way, we will implement the 8 cross 1 marks using the 4 cross 1 marks, which is definitely a special case. And once you know that how to use enable, you can also handle some other special cases. So this is all for this presentation. If you feel any doubt in this thing, then you can definitely ask in the comment box. So see you in the next presentation. In this lecture, we are going to obtain 32 cross 1 marks using 8 cross 1 marks. I was getting this question from you guys continuously, and it was not possible to explain this conversion in comment section. So I'm making this video, and we'll first see how we can have 64 cross 1 marks using 8 cross 1 marks, and why it is different to obtain 32 cross 1 marks using 8 cross 1 marks. If we have 64 cross 1 marks, we are going to divide 64 by 8, and